Hi, I'm Gwen from Nile. So when you build a SaaS, it can take a while to get the users and the kind of traffic you're really hoping for. So while you're working on getting the users, you have all those servers, your application backend, your database, and they're just sitting idle there, doing nothing, costing you money. What do? One way is to use a serverless database and a serverless backend, so you will only pay for the users you have and the activities they actually do, not while they're sitting idle. Today I'm going to show you how to build a serverless backend using Nile as a serverless database and deploy it using the serverless framework on AWS Lambda. So by using Nile as the database, we don't just get a serverless Postgres, although this is pretty nice. We also get Nile's virtual tenant databases, which let us isolate every one of our customers into its own virtual database where it's safe and secure. And we can also do things like back it up separately, restore it separately, place it on its own hardware somewhere else in the world. We have all this flexibility. But as you'll see in a second, the experience is that of a single Postgres. So you don't actually have to manage hundreds of databases as you start getting more users for your SaaS application. In the video, I'll show you how I'm creating the Nile database and setting it up. Then I will show you how we take a backend application and deploy it on AWS Lambda using serverless framework. And I'll also go with you over what it takes to take a normal backend and turn it into a serverless backend. And as a spoiler, it's going to be one line of code. So this part is going to be pretty short. Let's get started. Okay, so let's start by creating a Nile database. So I already have a bunch of databases, but for the sake of the demo, let's create a new one. Okay, so here's our new amusing moon. Okay, and one thing to notice is that even though it's a brand new database that I just created, we already have a table here. And this is what we call in Nile a built-in table, where we anticipate what you're going to need, since we know you're building a SaaS application. And we say, okay, if you're building SaaS, you have tenants, we will provide you with a table for them. It has an ID, tenants have a name, you can extend it with other columns. You can read more about what we do here in our documentation. In addition to the built-in table, we're going to need to create our own table for our application. So let me create that. And because we're building a to-do list, we're going to create a table for our to-dos. Here it is, it got created. If we take a look at the table, you can see that one of the columns is tenant underscore ID. Nile treats tables with a tenant ID column as a bit different. So we call them tenant-aware tables. And the idea is that because they have a tenant ID column, every row that you put in there belongs to a specific tenant based on the tenant ID in that column. What Nile does is split those into the virtual tenant databases. So every row belongs to one of the tenant databases, depends on the tenant that it belongs to. And then when we connect to a specific virtual tenant database, we can only see rows that belong to that specific tenant, which is what gives us this isolation and security that Nile provides at the tenant level. Same thing if we back up and restore, what we do is we act on the data that belongs to that tenant based on the tenant ID column. You can read more about our tenant awareness and tenant management in Nile's documentation. Now, before we move on to deploying and using our application, one more thing that we need to do here is to get a connection string to our database so we can connect to it from our application. Okay, and then so we went to setting and we chose connection. Now we generate credentials. and we copy the result. This is our connection string. Keep it safe because this is a connection string to your database. Anyone who has that will be able to connect to your database. Don't put it in a place where other people can find it. Now we're ready to clone and deploy our serverless backend. So we're going to start by cloning our example. Okay, so we're now in the example directory and we're going to need environment variables. So let's deal with those. We're going to take an example environment variable file and copy it into a real one. And then we edit it. So you see that the example environment file came with an example connection string. We're going to replace it with a real connection string, the one that we just got from the Nile console. And I told you to keep very safe. I hope you did not lose it yet. This is where you need to use it. Okay, we got environment variables and now we install dependencies. One important bit, we also need to install the serverless framework. And because we're going to use it as our command line, we need to install it globally. So you need to do npm install -g. That's what makes it global and serverless. Okay, so we got that. In addition, we need to install the local dependencies. So let's install those too. Great. Now it's time to deploy. This is pretty straightforward. Serverless deploy. Okay, so you can see that it was deployed and you can see that we got back an endpoint. This is great because this is the endpoint that we're going to use in order to try out our new service. So for example, if we want to create a tenant, we can run. And you can see here that it connected to the AWS URL that we got back when we did serverless deploy. And I got a response. This basically tells me that tenant called my first customer was created. I can also list the tenants. In this case, I'm expecting to see only one. Yep, here it is, same one. I can create a to-do for that tenant. Feed the cat. And I can list the to-dos. Pretty useful. So just to make a point, let's go back and see all those tenants and to-dos created in our database. Okay, so let's take a peek. You can see that we have feed the cat because that's the to-do we created. And you can see the customer here. So we have a serverless backend running on AWS Lambda that we deployed with a single line. And it's connected to our database and lets us use REST APIs in our serverless backend that insert things into our database. So this is our application, and I promised to show you how I took an example and turned it into serverless. So that's the last part. The example I started with is the Node.js Nile drizzle example. If you look up in Nile's example library, you will see exactly how we built the example in the first place. I'm not going to go over all that, but I took a normal backend using Express and Drizzle and I turned it into a serverless app. So how did I do that? Okay, so this is our Drizzle application. And the first thing you'll see is that we imported the serverless framework from serverless HTTP. This is half the victory right here. And then we did everything as normal. This is line by line exactly our Drizzle example, all the way to the end when I say export a handler and wrap this entire application. This is our Express app. Wrap all of it in serverless. And that's it. It does the magic. It understands which handlers we have in the application. It creates AWS gateway for them. It figures out everything we need. So we actually don't need to do a lot here, which is absolutely amazing. It just makes all those handlers that we have in the application available. So a small modification we had to do to get Drizzle to work in this scenario was, if we go to where we initialize Drizzle, you can see that we initialize a connection and then we connect. We don't do anything else with that connection at the top level. Because it's serverless, we only want code to run in response to HTTP requests. Nothing should happen on import or on load. It should only happen within the context of request handling. In the normal Drizzle example, after we connected, we had a few lines of code just running one query, making sure that the connection works and is good. We're not doing it here. And then you can see that we're actually exporting the DB. We didn't need to do it before. And then one last thing that we do here is that we need a configuration file with some settings around how we want the Lambda to run in AWS. So you can see that we're saying we want the Node.js 18 runtime. This is a bit old. You may want 20 by now. You can check the region. The environment variables are important. This is where we're exporting our database URL. Because it's a serverless backend, it is safe to put a connection string with the database username and password here. It will be in your AWS account, which is also presumably secure, and it will not leak in any way, shape, or form to the front end. So we are putting it here so that when you deploy, it becomes an environment variable in AWS Lambda, and that's how our serverless backend connects to Nile, the serverless database. And then the function basically says that we want a global handler that will handle all the routes. If you need more fancy translation, you want to modify the endpoint, you can actually get fancier here and specify different HTTP calls and map them manually. We didn't need to do any of that. And the last bit, serverless ES build, it's because we're using TypeScript and we're using it with ESM style imports. We also needed that. Now you know how to convert an application to run AWS Lambda using the serverless framework, and how to configure, how to deploy, and hopefully it's useful for you. As the next steps, obviously, clone the example, deploy it in your AWS account, have fun, and play around with it. And then if you want to create your own SaaS application using Serverless Backend and Nile as the serverless database, for a new SaaS, it will probably save you quite a bit of money to do things that way and not pay for machines that maybe you're not always using. If it worked, if you're happy, if you have feedback, if you have questions, join the Nile Discord. We are always there, happy to chat, happy to cheer for your new SaaS, happy to answer any questions you may have. Looking forward to seeing you soon.